Hi everyone, welcome to this one API hackathon with Hack2skill. So I'll be uh, taking you through the hackathon details, like all the details like submission, deadlines, problem statements, everything I'll be going through. So yeah, this is on the first page. There is a link to register, and so there are like three problem statements we have. First one is object detection for autonomous vehicles, and this is like AI based object detection use case. And second one is based on SQL DPC++, and third one you're free to use anything. Just I mean, it gives you more freedom to choose your use case and all the frameworks, libraries, but it should obviously have the Intel One API components, particularly AI and SQL. So these are three problem statements. You can choose any one of these and work on it. So we have three phases for this hackathon. In the first phase, you have to submit the ideas, in a PPT form, that like your use case, all the flow, like how you're doing the data processing, data pre-processing, and which framework are you using, which Intel AI analytics library you are using, all that kind of flow you have to show in your presentation. And uh, there is one GitHub link you need to follow and edit that by forking that. So we'll see that later. And in the second phase, you have to actually work on the problem, like all the implementation and all. After showing the presentation of idea, now we'll actually work on the problem statement and apply all these AI analytics toolkit libraries and the frameworks. So here you'll be like building the model to get the good accuracy, as mentioned in the problem statements. And once you build the model, now you have to deploy it. I mean, you have to create some kind of app and all. So for that, you should do some inferencing. So where again Intel AI analytics libraries will be really helpful in optimizing that. So once you do that, you submit your GitHub. I mean, all the code on the GitHub and all those things you'll have to share in the second phase. In the third phase, once you are done with the code submission and all, in the third phase, we'll call you for a 30-hour offline hackathon where we'll guide you even more. Let's say you have already applied the optimizations, but there might be more possibilities to add the optimizations. So in those 30 hours, we'll guide you, and we'll have the mentors also that time, so that you can further optimize it. And in that time itself, we'll also be having the presentations for all the like finale participants. And in each phase, like in the first phase, not everyone will be selected. Like if it's a good idea and you are utilizing the libraries well, especially the Intel AI analytics library, based on that, we'll be I mean, judging those, and uh, those people will go to next round. So yeah, each phase will have the elimination of some people if nothing has been applied. Let's say you have not even touched the AI, Intel AI One API libraries. So yeah, it's a must to have the One API libraries in your workflow. So deliverables, again, I already talked a few. Uh, yeah, so it's a must to apply AI analytics libraries, or the SQL DPC++, and idea should be submitted in a PPT format or PDF. Uh, yeah, and you have to clone this repo, or you have to fork this repo. There is this repo. You have to use this repo and change the README and submit it back to us. So for the first phase, the deadline is 7th of May. And can you go to other slide, Kavita? After idea submission, that if you do it on till 7th of May, then you'll have the actual implementation time. In that, you will be just applying all these things, code and all, everything you'll have to do in this phase. And particularly, if let's say you are applying the one API, Intel one API libraries, you have to show the performance benefits from it. Let's say you have trained your model in on a PyTorch framework. It already has the optimizations from Intel upstreamed, but we'll be showing like how you can further optimize it using Intel extension for PyTorch. So all that kind of benchmarking you'll have to do. Let's say you have installed stock version of PyTorch. Now you'll add the extension and add some 2 3 lines of code and do the benchmarking, like how much benefit you have got, and also the hardware details also you need to provide. Not only for training, it should be also done for inferencing, because inference is where you'll see more benefits on CPU, particularly with Intel one API libraries. So these are the judging criterias. You can see code quality. It should be easy to understand, and it should be reproducible, because I mean, yeah, we'll test it from our side also during the judging phase. So yeah, everything should be there, and code should be well documented with comments and all. And there should be some uh, yeah, comments should be there definitely. But if you can provide the document also to each code script and all, so that's a good thing. And then again, the AI analytics toolkit libraries, it's a must. Uh, so for both training and inference. And solution is yeah, it's like it should be original, and yeah, it should be original. Like it should not be from anywhere. Let's say you can take the base model from anywhere, but yeah, data set is different, so you'll have to apply it from yourself. All these things. Yeah. Can you go to the next slide, Kavita? So these are the timelines. You can see on 30th of April, registration will close. So yeah, you have to uh, register as soon as possible. And then in the idea submission phase, you'll have the time till 7th of May. And once you submit the ideas, they will be judging. And on 4th of June, you'll have to submit the actual code. So all the implementation all you have to share. And after that, if you are selected for finale, you'll be called for a 30-hour hackathon, in which like we'll further guide you and optimize your workload. So these are the timelines. Yeah, so this was all about the hackathon. For more details, you can definitely check out the link which we'll share. So yeah, the first poll question comes here. Like, can you show the poll question, Kaushik? It's regarding the registration of the hackathon for hackathon. After that, we'll start the workshop content. So yeah, I think people are voting. Yeah, please.
Participants, please do vote on the poll, which you will find on the bottom right hand section of the screen, where you will find a poll. with the query, have you registered to the One API hackathon or not? There are two questions, yes or no. Please do interact with the poll. Participants who haven't interacted, just on the bottom right section, you will find three square, triangle, and a circle shape found over there. Just click on it and go to the poll section and vote on the poll right now.
Yeah, there's many people to vote. Please use the poll option. To just you need to tell that if you have already registered or not. There is still time left to register, but yeah, we just want to know that if you are already aware of the hackathon and already registered or not. So yeah, I think from the crowd, I can see half of them have already voted, and like less than 5%, like around 5% from the who voted have not just registered, but otherwise 90 to 95% of people have already registered, and we are seeing more votes coming, and most of them are have already registered. So yeah, Kaushik, I think we can close this poll uh, for now. We can start with the presentation. Okay, so if you have already registered, that is fine. That's good. If you have not, you can just follow the link. We'll provide the link, and you can just register. And you can also take the call after. I mean, yeah, you can definitely register. You'll learn about all these libraries and all, and you'll see that it's very easy to apply if you are already able to build the model and all in as a data scientist. Applying these libraries is very easy. You'll just see the a lot of optimizations from these. So hi everyone. Now let's start the actual presentation, or the workshop, hands-on workshop. So in this workshop, I am going to cover like how you can accelerate your AI workloads. Let's say if you have a machine learning model training inference, or a deep learning model training and inference, how you can apply the Intel oneAPI libraries, particularly oneDNN and oneDAL. So oneDNN is mainly for deep neural networks, and oneDAL is for data analytics. So yeah, oneDAL will help you accelerate your machine learning workload, and oneDNN for deep learning models. So this the agenda for today is we'll see like what is there in the Intel AI analytics toolkit, and then these are all these five are the five main components of this toolkit, and so we'll cover each component individually, how you can use these in your existing frameworks, or in your existing libraries. So first we'll see Intel extension for scikit-learn, that is applied on top of scikit-learn, and then modin, that this replaces this you can use instead of pandas to optimize your data pre-processing things on data frames. And then PyTorch, for PyTorch we have this Intel extension for PyTorch that you can install on top of your PyTorch workload. And then TensorFlow, you can install whole Intel distribution of TensorFlow. Then there is this neural compressor that is mainly for inference optimization. So these are the things we'll cover. Uh, so let's start with the one API, because one API is the thing that is the tool that will like power all these libraries. So one API is like a cross architectural programming model that allows you to uh, like create a program and run it on a multiple hardwares without needing to change a lot of code. So let's say if you have implemented your code for CPU, now if you want to use it on GPU, you just need to change a few parameters and you are able to use it on GPU or FPGA also, like other accelerators. So that is the main advantage of one API. Apart from it, it has like it contains these four things. Compatibility tool. So compatibility tool is basically it's a DPC++ tool that allows you to let's say if you have a CUDA code that is like bound to some hardware. Now, if you want to convert that code to if you want to make it hardware independent or hardware agnostic, you can use this DPC++ compatibility tool, so that like it can do some further optimizations like parallelization and all. And then in the languages we have C++, Python, all these optimized with the libraries. Then we have the main libraries, that is like that will optimize all your workload on the underlying hardware. And we also have these analysis and debug tools. These are to see like how your code is performing on the hardware. And you can see like CPU utilization and all these things in these tools. So one of the tools is this vtune. And one of the examples for this and on top of these we have these all these frameworks which we use as a data scientist. So we can see TensorFlow, PyTorch, all these are optimized with these libraries and all these things. So one example for one API is, let's say we have uh, Intel extension for PyTorch, and so Intel extension for PyTorch can be easily used with on CPU. Particularly it was for CPU. Now Intel's GPU are already here in the market. To use it on a GPU, Intel GPU, you don't really need to do anything. You just need to just uh, I mean export your model to XPU and all. And the API is very similar, like nothing you have to change, just package is different. So that is one of the examples. Like PyTorch you can use on CPU and GPU also with the help of one API only. So Kavita, can we go to the next slide now? So here if we can see at the bottom, we can see these oneMKL, oneDAL, oneDNN. These are 3 4 main libraries which help you optimize the AI frameworks. So oneMKL is math kernel library that helps optimize the linear algebra kind of operations. And then oneDAL is for data analytics, machine learning kind of libraries. Then one DNN for deep learning, TensorFlow, PyTorch. So these are three main libraries. One CCL is also there for distributed training and all. So yeah, these are all the frameworks optimized with these four libraries. Uh, can we go to the next slide, Kavita, now? Yeah, so all these are covered in AI Analytics Toolkit. Yeah, so we can again skip this one. Uh, yeah, so we'll start with the one API AI Analytics Toolkit. So one API AI Analytics Toolkit is a like bundled set of all these like popular frameworks and with Intel optimizations applied in it. So let's say if you have TensorFlow, it will be there, but with optimized version of it, optimized with one API. Similarly, PyTorch, it will be there. It will be optimized with Intel extension for PyTorch. So all these popular libraries and frameworks are there in this toolkit. Uh, so like it can, let's say if you are doing some, you are making the workflow for your problem statement, you might need data pre-processing. So for that, and then you'll be also training the model in PyTorch, and you might also compress your model for a faster inference. So all these, like, you don't have to install again and again. So that's why this AI analytics toolkit can be beneficial. And not only that, we also have this Intel optimized Python that optimizes your NumPy, SciPy, and all these libraries with one MKL. So basically, oneDNN AI analytics toolkit has most of the useful frameworks and libraries. But you are not limited to use this. You can, if you want to, let's say if you want to only work with PyTorch, you can just install standalone version of Intel optimized PyTorch. That is also possible. But for a like whole flow, it's good that you utilize the whole AI analytics toolkit. It also has the conda environments for each of these frameworks. So let's say for TensorFlow, you'll have the conda environment, and then PyTorch also you'll have the conda environment. So yeah, it already has the all those environments. So this is the optimization strategy from Intel. So first we try to like apply most of these optimizations or upstream them to the open source version of the framework. Let's say to the to TensorFlow, we already upstream a lot of optimizations based on CPU and all these low level optimizations. If those optimizations are still not upstreamed or in review with that frameworks team, then we also provide the extension, those optimizations in the form of extensions. Then we also have the whole distribution of that framework with optimized version. And if you want further optimization, you can definitely try these OpenVINO and neural compressor and all. And all these can be installed using PyPy, Anaconda, Aptium. We can skip this file, Kavita. Yeah, whole. So yeah, I have till now I have talked about the components of one AI analytics toolkit. Now we'll take each component and yeah, and we'll go through how you can use those frameworks and libraries. So now comes the depth cloud registration process. So I'll go through whole procedure. Like I'll not register from myself, but my side, but I'll like walk you through the website and all. So now about the depth cloud registration, the question comes is, have you already registered on depth cloud? I think poll is already up.
Yes,
Okay, this is
Aditya.
your hackathon. Yeah.
Live. Participants, again, it's a request. Just go to the bottom right of your screen. You must have seen a pop of the poll. Please do make sure you actively participate in the poll and let us know where you are currently standing in terms of registering on DevCloud, and have you used it or not? Like, registered and you are yet to use, or you are currently registering after you received the mail and WhatsApp from our side. So make sure. Yes, you can. You can register. You can register anytime, anytime. But make sure that you register at the earliest.
Kavita, can you try stop presenting? I'll share my screen. again. Can you see my screen?
Not yet, Aditya.
It's saying resume your presentation. Let me stop sharing again. Present now. A window. Just a second.
Aditya, once you click on the window, hit the share now tab.
Yeah, I have done it. It's saying resume presenting. I am not sure why is it.
I think Kaushik, just take off his presenter rights and give him back.
Yes, yes, Kavita. We are doing that.
Let me.
Hi, Aditya. Could you try now? We have reset your permissions again.
Yeah, just 1 second.
Meanwhile, participants do interact with the poll and let us know what's the status of your registration on DevCloud and how well you are utilizing oneAPI. What all features you have explored yet? Please feel free to drop it in the chat section of the Meet.
So while Aditya waits for fixes the screen sharing issue, let's explore whether you are having any difficulties in signing up with the DevCloud. Let us know if you are having any issues. Post your questions on the chat window. You can address those things. You can use the DevCloud link that is posted in the chat window. Click on the sign up button and enter. If you already have an account, enter your credentials. Otherwise, create a new account. It's a free account. And signing up for this DevCloud is pretty important for this workshop. So Sim Kaushik has mentioned he's getting some error. What's the error? Is it? Can you please elaborate on the error? What's the error that you're facing?
Kaushik, I think Aditya has joined, given the presenter rights.
Yes, yes, yes. We are doing
Thank-
that, Kavita.
Few
Aditya,
users are reporting they're facing a status code 500 error. Is it if it's part of your sign up process you're getting that error? I'll suggest you can refresh the browser and try again.
Aditya, you have been provided the moderator access again. Could you please try sharing your screen?
Yeah.
If anyone's still facing issues with sign up, let us know. I think Aditya Dwarak is able to sign up now. The 500 issue is resolved.
Aditya, you are the moderator again. Could you please try once again?
Aparna Mishra, you're still having a issue with 500 error. I'll recommend please refresh your browser and try again. Aditya, you might want to try a different browser. If you are using Chrome, try Edge or some other browser.
Yeah, so I am trying that. Meanwhile, Vasudha will share the live file.
Okay, sounds good. Thanks. Aditya.
Yeah.
So Vinay Sharma, please wait after you log in successfully into the dev cloud. Aditya will explain what we need to do after we sign up.
Kaushik, please make Vasudha the presenter.
Kavita, Vasudha is already one of the mod. Kavita and Vasudha and Nazneen.
Yes, Kavita. I'm sharing the link for the lab files that Aditya has made in the chat.
Vasudha, are you able to share the screen presentation?
Anish, so I have shared the link for the GitHub repo for this session. Should I share my? I think Aditya have shared his screen.
Okay.
Okay, thanks.
Yeah. So can you see my screen, right?
Yeah, yes,
Yes,
Aditya.
yes.
Finally, all good to
Uh,
go. Go ahead.
Finally, Firefox saved you.
Yeah, only, but it's only sharing the Firefox. So for the depcloud registration, what we need to do is depcloud.intel.com. So I wanted to know the results for depcloud registrations, Kaushik.
I think many of them have successfully signed up. Few had issues. I think they are getting resolved.
Okay. Yeah. So if any one of you having any issue, please can you explain your issues, like uh, what's the issue you are facing? If not, I mean, so Kaushik, how many of how what percentage of people have already registered?
For the dev cloud, right?
Yes, yes.
So according to the polls, like registering now, out of 104, we had 48 who had said they are registering now, and 26 had said they had already registered. Two had said they had registered but yet to use. So 25, close to 30% have said that they have already registered, and close to 50% are saying that they are registering.
Okay. Can you see my screen, right?
Yes, yes, Aditya, we can.
So I will just go to the procedure again. So let's say if you have already registered depcloud.intel.com. If you go here, you will sign up. Let's say if you are here, you just need to click on this. Don't click on anything related to Edge or OpenVINO. We want to work on oneAPI because it has all the AI analytics toolkit environments and kernels. So we have to click on work with oneAPI, and you will see this kind of page, like it having all the documentation and all. Here you will click on the get started, and on the get started, you will see in the bottom, you'll see connect with Jupyter Lab. So you can click on this, and your Jupyter environment is ready. It'll again ask to click here to sign in. You can just do it. It'll automatically fetch the login and all from the website. So Vasudha, any questions regarding the depth cloud registration, particularly like if you want to highlight related
Uh,
to this
no,
in the chat?
Aditya, right now I can't see any question related to DevCloud. Initially, they were facing this login error of 500. I think it has been resolved.
Okay, okay, that
Yeah.
sounds fine.
So Aditya, you
Thank you.
can get started. Probably we are there to help people on the DevCloud sign up if they face any issue. There
Yeah,
might be some confusion with OpenVINO and oneAPI related DevCloud, but let's see. Hopefully, till now we haven't seen anybody having that issue. But yeah, if anything comes up in the later stage, we can address that.
yeah, sure, Anish. Kavita, you may need to share your. Uh, let me try. Uh, For entire screen, it's not allowing me to do. Okay, so I can share my screen. No, can you see?
Yes, Aditya, it's visible.
Yeah. So again, let me reiterate the procedure for the cloud. Just uh, sign in, and then all these details filling, and you'll get the code. Again, I showed you that you need to click on the work with one API, and then get started, and then on get started page you come to the bottom, you'll see this connect with Jupyter Notebook. Here you'll see the all your Jupyter interface. So this is what it will look like. We will see uh, uh, more on this. So if you are here, sorry, if you are here, you are all set up for the dev cloud. We'll see the lab later, just after a few files of presentation. So so let me start with the components of this AI analytics toolkit. So first, again, I want to highlight the AI analytics toolkit. It has all the important frameworks and libraries with optimized version or extension. So you can see oneDNN is optimizing your deep learning frameworks. OneMKL is optimizing your Intel uh, Python, and oneDAL is optimizing your machine learning and data analytics libraries. So all these are there. So AI analytics toolkit is like again the same thing. Multiple frameworks are here with optimized libraries, these oneDNN. So if you are using oneAPI AI analytics toolkit already, you are yeah, by default using these all these libraries. You just need to do some kind of code changes, one or two lines of code changes to get the benefit. So we'll see that thing later. So and here again the point is, either you can use the AI analytics toolkit to get all these frameworks and libraries, or you can also install them individually. Standalone version is also available. So we'll see that.
Sorry to interrupt, Aditya. Some of the
Yes.
participants are still facing some issue while uh, enrolling with the Intel Dev Cloud. Can you quickly repeat the steps for them?
So what issue for currently? I mean, can you
So
specify a little bit
yes. So
so
one
that?
of the participants is not able to see connect with the Jupyter Notebook. So can you open that page where we have to scroll down and launch the Jupyter Notebook?
Okay, so is someone seeing this kind of issue? Server like it's loading and all. This is a temporary issue. You can just reload it, and I mean you can re-click on the launch Jupyter if this thing is taking a lot of time.
So Aditya, probably this is not the issue. Probably they might be facing issue with the initial sign up. They are
Okay,
not able to figure out. Maybe you can go to the getting started page and tell them where to find the launch Jupyter Notebook.
yeah, sure, Nish. Quickly do that. Uh, I'll share my browser again.
So we are trying to re-emphasize on signing up the dev cloud, because the signing up dev cloud is a very important piece of this entire workshop, as you will all be executing this code on the dev cloud machines.
I think you should be able to see my entire screen now, right?
Yes, Aditya, we are able to see your entire
Yeah. Okay. So I'll again open the oneAPI Dev Cloud. So after you have got the code to like one-time password or one-time code on your email, you just fill it, and after you have filled that code, you should open this thing, devcloud.intel.com oneAPI. So once you open that, you should see this page. If you have already registered, you should see this kind of thing, sign out, all these things, and it means you have got some user ID, and you can just click on the get started. And yeah, just click on this connect with Jupyter Lab. So these three things after you have already registered. So these are the three things you need to do. Just open one in depcloud.intel.com one API, and it will also add the home, and click on the get started, and then connect with Jupyter Lab. Launch Jupyter Lab. So once you launch Jupyter Lab, you should see this kind of interface like Jupyter environment. So now I'll go back to the files to cover some content for the libraries. So this page is having all the details like how you can install via different ways like PyPy, Anaconda, all these things are there here. You can go through it later. So now let's see the oneDAL library that is going to optimize your scikit-learn and XGBoost based libraries. Okay, so before starting the oneDAL, I'm going to emphasize on what kind of just a high level view of optimizations Intel's all these libraries are doing. So this vectorization is one of the things which is like happening under all these libraries at hardware level. So why is it possible is because let's say if you have these instructions at AVX, advanced vector instructions. So our older versions of CPUs used to have this 128 bits for a single instruction. And now with advanced features, let's say our current, not current, like even our older generations were having this AVX 512, that is advanced vector extensions 512. So it allows you to have a instruction set of 512 bits. That means you can save your data like FP32 uh, FP32 integer, 16 FP32 integers you can save in this instructions, and that means you can run multiple operations on these. You can run 16 multiple operations together. That allows you to do the vectorization. So in vectorization, you'll do operations at the same time, not only for a one data, but on multiple data. So this kind of instructions, this AVX512, allow you to do the vectorization, and all this happens in the background. You don't need to do it like all these lower level libraries are doing all these optimization. So this was vectorization. That was one thing, and there is this parallelization also. When you are running your code, what happens is your some operation is there in the code, right? And that operation uh, will run as a process, and that process can be like divided into multiple threads. So to take advantage of that threading, I mean that those threads running on multiple cores, we also have this parallelization. So multiple, so that like execution can be completed early. So that's why this parallelization can be useful. For this, we have this OpenMP, Open Multiprocessing. Uh, so this Intel has optimization on that also at the lower level, at the core level. Then we have these again. I told you that this AVX 512. This was the feature in our second. This is there from our second Zen Xeon CPUs. We have a Xeon series, second gen, third gen, fourth gen is also there. Sapphire Rapid, that is like very new. So they had this AVX 512. Uh, Not only that, it can also run your int8 a quantized data type. So what int8 will do is, let's say if your FP32 data type is there, if you run int8 data type, like it can like it saves on the memory and also the computation. So all these optimizations are there in these hardwares, and in our upcoming frame, this CPU Sapphire Rapid, we also have this a new instruction set, that is AMX, Advanced Matrix Extension, that allows you to have a 2D registers. So you can even have the better computation and more data can be stored. And one special feature of this Sapphire Rapids is this: it can support bfloat 16 data type. That is a very special type of data type. It can be easily converted to FP32. So it basically helps. It is used in auto mixed precision training or inference. So this was some kind of low level optimizations and hardware details. Now let's come to the Intel extension for scikit-learn. It's powered by oneDAL, that is uh, one API data analytics library. So here what you need to do is I'll just go to the code part directly. So all these all, let's say if you have the scikit-learn library in Python is very useful for it implements all the machine learning, most of the popular machine learning libraries, so that you don't need to code them. Let's say if you're doing the using the linear regression, you'll have to, like, if it's not for the scikit-learn, you'll have to do the, I mean, you'll have to fit the line and the equation and do the back propagation, all those matrix multiplication. You have to do them then those things manually. But scikit-learn provides you the feature that all those libraries are pre-implemented in that. You just need to provide some kind of input, some parameters for tuning it. So scikit-learn is very useful for machine learning purpose. So on top of scikit-learn, how you can apply the Intel extension, that is the point. So for that, we need to install it. We need to install Intel extension for scikit-learn. So for installing, you can just do this pip install scikit-learn Intel X. This is the one-line command you just need to add on top if you're on top of your scikit-learn library. And to use it, what you need is, you can see here, this is the support vector classifier. You can see this your existing workload with scikit-learn on top in the left to top. From scikit-learn, you are importing is support vector classifier and then getting the data set and then fitting this SVC on a data set and predicting. Now, to use this Intel extension for scikit-learn, all you need is just add these two lines from sklearn x import patch sklearn and do the patch sklearn. Now everything running on your scikit-learn will be like optimized with Intel's all those vectorization and parallelization and more operator level optimization. All the things are happening under the hood. So these two lines you add, and you can see the speed up here. So it's stock scikit-learn versus Intel optimized scikit-learn. You can see by adding these two lines, k means fitting got with it's with a different parameters. You can see 4 times of speed up. So yeah, I mean, you can get really good speed up if you add these two lines on top of your scikit-learn workload. And if you want to do the benchmarking, let's say if you want to show that how much speed up you got, all you need is you can just unpatch also this from scikit-learn from sklearn-x. You can import unpatch sklearn and you do the unpatching. So what it will do is it will remove the extension from the code coming further in this script. So this is for a script in the script. Again, these are the numbers. You can see either it's fitting or training or the inference. For all the cases, you should see very good speed ups. We'll also see this thing in the demo. So this is modin. Modin is like a drop-in replacement for pandas, which enables you to like run your data frame based operations on multiple cores. By default, pandas is not able to take advantage of multiple cores available in your machine, but modin is is the library which can provide you this feature. Not only this, if let's say the data set is very huge, to use to do the parallelization on those huge data sets, Modin uses these backends, Dask, Ray. These are distributed libraries, Dask, Ray, or OmniSci. There is one more SDK from Intel for especially for Intel GPUs. So Modin uses these as a backend for huge number of I mean large data sets. So similarly, for Modin also, you can just let's say if you are using pandas for your data pre-processing. Now to take advantage of Modin, about the Modin is like heavily contributed by Intel. Like Intel has been contributing to Modin very for a long time, and yeah, so it's kind of a it's having all the Intel optimization. Now, if we see pip install, so using Modin, what you need to do is pip install Modin all. All means it's installing all the backends, Ray, Dask, or HDK, OmniSci. So it's having all the backends, but you can also specify which backend you want to use. Let's say Ray you want to use, you can just specify Modin Ray in place of all. So once you have installed it, so earlier you might be having this import pandas.pd. Now what you will do is import modin.pandas as pd and do everything uh, like you were doing for pandas. You don't need to think of that. So with this, you'll be able to again see this kind of uh, you should be able to see this kind of speed up. Let's say if you're reading it's like showing the speed ups for multiple operations. So this one line you can just apply. Before going to deep neural network, oneDNN, I'll just show the demo for this. So hope you are here. So you might be seeing a lot of things here, but just so for the steps, I think I have already shared the GitHub link for the instructions.
So
Vasudha,
Aditya,
have you shared?
yeah, it's shared. Aditya, can you quickly go to explain how to clone it, how to go to the terminal and clone this thing?
Yes, Anish. Let me do it. Hello?
Yes, yes. Go ahead. Go ahead and launch the launcher and show them where the terminal is and how to clone it.
Okay. So once you uh, once you open your once you click on this launch Jupyter Lab, you'll see this kind of Jupyter Lab environment. It takes so here like this. So you'll see some welcome notebook, and if you click on the launcher, you'll be able to launch the terminal here. You might be seeing some kernels with environment with oneAPI based environments, Conda environments. So please ignore those. Just click on this terminal, and when you open the terminal, uh, it's already having the oneAPI activated. So if you see Python, you'll see this Intel extension, Intel Python. So you don't need to do this. You just clone it. Git clone. Here you can just give the command git clone that repository. The link you might have shared already. So here, for the instructions, you can follow this guide I have shared on my GitHub. So this link also, Vasudha, you shared in the chat.
Yes, Aditya, I have shared.
Okay, so this my personal repo is having the instructions to follow, and the cloning you need to do for this repo, GitHub one API source, one API samples. So this thing you need to clone in your terminal. Just do it. I have already done it, so it will not happen for me. So let's say if you already have the repo, let me go to the repo. So if you have cloned it, and one more thing, in the left side of it, you will see this folder file browser. Here, from here, you will be able to like navigate to different files. So here you can also increase its size. So you can see one API samples. Once you
Aditya,
cloned it,
sorry to interrupt.
yes,
Can you show the participants how they can launch a terminal?
okay. Yeah, so when you clicked on the get started, you might be seeing this welcome.ipny. This may be helpful later. You can check it out, but for now you can just click on the terminal here. I mean, let me open that. So in the left side of this left top, you will see this new launcher. This is the button to open everything on the adapt cloud. So here, once you click on this, you'll see multiple kernels from one API. Some of these you can also create, but from one API, you'll see this Python 3, PyTorch, AIKit, TensorFlow, and here you can just launch the terminal. Click on the terminal and git clone here. You'll see this one API samples repo folder in your home directory. So for scikit-learn sample, all you need to do is click on this, double click on this AI and analytics, features and functionalities, and you'll see a lot of samples. You can try these later. For this hands-on workshop, we'll be opening this SVC, support vector classifier based notebook. So once you opened it, you just click on this IPYN, that is notebook file. You can also run this Python script from terminal, but for an interactive session, we are opening this. Let's see. So once you have opened it, you should see this kernel automatically selected. Python 3 one API, it should be automatically selected. You don't need to do it. If in case it's not selected, if some other kernel is selected, you can just click on it, scroll down, and select. So that is the thing here. I'm showing again in one API samples, AI and analytics, feature and functionality. In the first folder itself, it's there. Actually, I have already run it, but yeah, I'll run it again and with the explanation. So again, these are all scikit-learn related things. You can just time is imported for measuring the time for training, and then metrics to see the accuracy and all, and model selection. From model selection, you can do the for data set, you might need to split it into train and so for running this shell, what you need to do is control enter, or you can just uh, click on this play button. I'll do the control enter. So it's importing the libraries. It's yeah, it's importing the all the modules. Now here we are fetching the data set, that is uh, we're using this fetch OpenML, and it has already downloaded it. Now we'll do the train and test split, and you might be seeing this in the first cell itself. You are seeing this uh, activated, but it's coming from, but it's not really applied, I would say. Here is the main uh, enablement of scikit-learn extension happening. So you can see using Intel extension for scikit-learn. From scikit-learn extension sklearn X, you are uh, importing the patch, and you can see enabled. Now we do the usual things: parameters defining for support vector classifier, and here we are fitting our model. So we have started noting the time, and yeah, we have imported the support vector classifier, and then we are fitting it on our data set, and we'll finish the time after our fitting finishes. So I'm running this node, this cell. It's you can see here on the star. Star means it's still running. This cell is still running. So it's fitting the uh, model or data set. So when okay, you can see it will show execution time with the Intel extension for scikit-learn took 56 seconds. Now here we are measuring the accuracy and all. So F1 score 0.82 and all. You can just note it down, or just you can compare it later when we'll unpatch it. So now here we'll unpatch the scikit-learns to see like how much speed up it could give. Unpatch it and do the same thing. But the thing here is it's gonna take a lot of time. Uh, so I'll let it happen in the background so that we can save some time. So this is after unpatching. You can see the result from my previous run. When I ran it was happening in 6:53 seconds. And this much time we don't have for the workshop. So yeah, I would like to skip this thing. Skip means let it run in the background. You can also do it. We'll just go to the presentation again and do something else. I mean, I mean, learn about oneDNN and all. So once it finishes, it will show that it has finished in this many seconds, and you can do the accuracy check again. This will be exactly or very similar to this. You can see everything is same. Accuracy F1 score is 0.82 only. Uh, Nothing has changed in terms of accuracy. Here is the performance comparison. So with the Intel extension for scikit-learn, it took 56 some seconds, and here it took 673 some seconds without optimizing it with Intel. So we can see 11.75 times of speed up you could gain just with just pip install Intel uh, scikit-learn extension and adding that patch. So this could this kind of thing we want you to try in your hackathon workload and show that you also got this much of speed up. And in terms of accuracy, there is no change. You can see. Now let me, so it's still running. You can see. Let me go back to the presentation and quickly cover the oneDNN part. So if now we'll see the oneDNN, like how oneDNN optimizing your deep neural networks. So oneDNN is again coming from oneAPI. So we already talked about the vectorization, parallelizations. All these things are happening in oneDNN also. But apart from that, it also focuses on popularly used operations in deep neural networks. So let's say convolution and LSTM, RNN, all these operations are like very frequently used in uh, CNN or CNN based models or any language based model. So so Intel has optimized all these operations with the help of oneDNN. So what it does is it replaces your actual eigen. So in TensorFlow or PyTorch, we have this. Originally, they use eigen operations, and oneDNN replaces them with the optimized version of them, and they itself do the operation faster. So this is the oneDNN, and it can also support all these different kind of data types. Bfloat 16 it can support, int8 also it can support for faster training and inference. It can also leverage the OpenMP, that is multi-processing on top of itself, on top of any AI workload. You can also use OpenMP to utilize the manual parallelization. So let me just quickly go to the Intel optimization for PyTorch. So so Intel optimization for PyTorch with the help of oneDNN has all these features. Easy to use API. You can see in the code left here, just one or two lines of code you have added in Python script itself, and you will be able to optimize your model. So operator optimization, it provides quantization also. It has, you can convert your FP32 model to int8 or bfloat 16. Graph optimization it provides, because in neural networks everything is about graph only. Like we are passing the data set, and it's ultimately going through a graph, and and we need to optimize the graph. Let's say we can fuse two operations, and in a single cycle, two operations can be done by fusing. So this kind of operations it's doing. And there is one more optimization that is for Intel specific. oneDNN is Intel hardware specific optimization, that is channel last. So it's mainly for CNN based models. We'll see that later in the coming slides. So for the code change, let's say if you have uh, this I think this is already here also. So let me talk about the memory layout, like channel last thing. So Intel, there might be so for CNN based models, input are images, like colored images. They have like three color channels, like red, blue, green. So we can see there are two formats for this. One is NCSW. N is for number of images. C is for channel, like which channel are we having in the 4D matrix, and then height and width. So one format is this NCSW, other is NHWC. So Intel oneDNN uses a different kind of format, that is like blocked format, that is very close to this NHWC. So it's so that like the conversion from NHWC to that blocked optimized format is easy. It allow you to cache coherency and also vectorization. So all those things are easy with NHWC. Uh, so we recommend you to use NHWC, that is channel last, like channel is in the end. So this is one of the optimization you can try in your workload. Now we'll see the actual how to use Intel extension for PyTorch. So for that, first you need to have the PyTorch for CPU. You can see pip install torch. This one line command. This is from official PyTorch website only. You just need to make sure that it's for CPU. Then second thing that is main here is Intel extension for scikit PyTorch you need to install. So one thing to note here is you must have the same versions. If you have the PyTorch 1.13.1, or I would say major version should be same. If you are having 1.13, you should also have the IPEX Intel extension for PyTorch 1.13 only. You cannot have 1.12. So once you have installed it, now we come to the code change part. So you imported Torch Vision model. You have got the ResNet 50 pre-trained model. This is for the inference mainly. For training also it's possible, but here we want to show one more thing. So you do the eval and get the data. All this is normal PyTorch things. Now the code change required is you import this Intel extension for PyTorch as IPEX, and you already did the model eval, so that like it's more for inference. Now you apply this IPEX optimize. Now the model is optimized with IPEX. With this itself, you will be able to see some gains. Not You'll not see a lot of gains, because sometimes you might not see, because as we already saw that Intel's optimizations have already been added to the PyTorch. So some gains are already there in your base results. So from this itself, you'll see the benefits, but main benefits come from this uh, JIT tracing. So JIT tracing is so it's so in PyTorch we have two modes. One is imperative mode and other is torch script mode. So in imperative mode, what happens is it uses Python interpreter to run all these inference. But what it the disadvantage of that is Python interpreter can be slow, and also if you want to deploy it on different edge devices or any other in C++ environment, it cannot do. Like by default, PyTorch dynamic nature and Python interpreter cannot do this. So to avoid that thing, we have this torch script mode. What it does is it takes all your operations from the dynamically compiled neural network. It takes all the operations in the flow, and what it does is it creates a torch script mode. It happens using this JIT trace. So your all the code and all is now converted to torch script mode. The torch script mode can be run into multiple interpreters, and with and it the one more advantage here is it can run with just-in-time compiler, that is JIT compiler. So yeah, I mean, if you have converted your model to torch script, it's kind of a intermediate representation for PyTorch model, and it's very free to be used on any different kinds of compilers and different kinds of interpreters. Like especially for C++, it can be used, and C++ is pretty fast in comparison to Python. So torch script is very useful in terms of model deployment. So here in the code, what we are doing is we are converting our model to trace format, that is JIT torch script format, and we are freezing it, because by freezing we mean we don't need to train it again now, so that we can add more optimizations in here. So these are the this is from torch only, but optimizations are really included in it from Intel extension for PyTorch. So let me just quickly show the demo for this with PyTorch. Then if so, yeah, my previous run for scikit-learn is also completed now in 670 seconds. So yeah, close to, I mean, it took a like lot of 10 minutes approx, so 11 minutes. So we can see like you can just run other shells and you will see this kind of 11, 12x of speed up for scikit-learn extension. Now let me quickly go to the PyTorch demo. So for PyTorch demo, you can just go to that features and functionalities again, and there is this Intel PyTorch extensions inference optimization. You just need to double click on this and open this notebook. So for this, you need to select the kernel PyTorch. This PyTorch AI kit. It has all the things, but for me, it's I have created a different environment. This you can create. You can also create this environment because in my original Python environment, I installed some things and it got different things for GPU and all. And it got little messy, I would say. So I had to create a different environment. For in creating the environment, you have the you have that you can follow this script, but you for this session you don't need it. You already have the PyTorch AI kit. You can just select PyTorch AI kit. By default, it will be automatically selected, but still, just make sure that it's here. The kernel is PyTorch AI kit. Now this notebook is all about the applying all the Intel extensions for PyTorch optimizations and mainly for inference. So we are importing, and then about the model, it's again an object detection model. It can be useful for your first problem statement. So we are using the ResNet 50 backend. So I am importing these libraries, I mean modules, Torch Vision, Matplotlib. I've already done it. So let's just run one by one. These are the functions for time measuring and like plotting and all. And here we are loading the model. So we are using this faster RCNN model from Torch Vision only. So Torch Vision dot models detection faster RCNN. We'll pick the weights and all from here. Then we'll convert it to evaluation mode so that it won't store the gradients and all. So these are some helper function will be needed. So weights, I've already done it. Weights we have got for this. Now here what we'll do is we'll run this. We'll run the inference. In inference, what we are doing is, so this is the inference function. What we are doing is with torch.nograd, no gradient calculation, since it's inference. We are passing the images input to the model. So this is the inference. And then we are doing the warm up, and then here in actual we are computing the time. So we are just running the inference for this model with the help of images and calculating the average time. So this is the thing we are doing here. Now we'll run the this is like a baseline version of PyTorch model inference for faster RCNN. So model we took, I mean we loaded the model and we calculated the time. So it will show some kind of this 785 milliseconds it took average for a inference. And then if we convert it to channel last converting the model to channel last is nothing, just you can use this memory format torch.channel_last. But you also have to make sure that model is also used to this channel last. So we are doing this and running it running the same thing, getting some kind of little bit of speed up with channel last itself. Now here we are applying the Intel extension for PyTorch. We are doing the same thing, loading the model, doing the channel last, and now applying the Intel extension for PyTorch. to model ipex.optimize, and it's done. So here, if you run it, you will see. We run, if you run it, you'll already see some kind of with ipex itself. You will see from baseline. What was the baseline? Here I think I missed some imports, but what you do is, like, here it was 670 something, 770 something, and with the ipex optimization and channel last optimization, you'll be able to see 533. So it's already 1.3x of speed up by adding channel last and ipex. And one interesting thing about the channel last is, it's from 1.13 version, it's automatic. So ipex will do all this channel last thing for you, like under the hood. You don't need to worry about it. So you can skip this channel last thing also if you want to, in your PyTorch workload, if you don't want to do it. But it's just to show that manually, if you're doing, how much benefit you can do get. So that was the ipex optimization. Now if we see the torch script based optimization, because Intel's optimizations are mainly done during the runtime, during the just-in-time compiler runtime. So torch script model will really see a lot of speed up in that and optimization. So here we have loaded the model, and to apply the torch script, what we do is we trace the model to convert it to torch script mode and then freeze it, so that we don't need to. Freezing has like some benefits even for TensorFlow also. If you freeze your model, it removes some kind of unnecessary things, and also it can take some fusion related, graph fusion related benefits. So freezing is always good if you don't want to train your model further. Here again, the same thing. Inference time optimized. We are calculating. We got 353 milliseconds from base of 7 something, 763. So with these, for inference, you already got almost 2x of speed up, and it also depends on which model you are using. You can see more, but in general, like 2x is very easy to get with these, especially with these JIT tracing touch script mode. You will see minimum 2x in most of the cases. So that was the how you can use your Intel extension for PyTorch for inference. So it's very recommended that you, for inference part, you apply this touch script mode, because most of the Intel optimizations are included in that. And if we see, you can also further look into this part here. This is the like Hugging Face based model, where we want to show the quantization using Intel extension or PyTorch. So you can run it, and with the help of quantization, you will be able to see for inference, you'll be able to see 3x 4x of speed up uh, with the help of quantization using Intel extension for PyTorch. So yeah, it's recommended that you first do, for inference part, you first do the convert your model to TouchScript mode, and you might get already 2x kind of speed ups, and even for further optimization and tuning for inference, you quantize your model. Quantization can also be done using this Intel extension for PyTorch, or also there is one more tool, a neural compressor. So let me come back to the slides very quickly. I'll finish. So in TensorFlow, and no code change is required. Like we have all the optimizations upstreamed on the official version of TensorFlow. In official version, you just need to enable this environment variable, and or you can also disable it to see like how oneDNN is applying the optimizations. So this environment variable, you can remember to see like to do the benchmarking that how much improvement oneDNN has provided for TensorFlow. And we also have this Intel optimization for TensorFlow that is having a few more optimization, particularly the multi-threading and all optimizations if you want to use. So it includes Intel OpenMP that allows you to set like how many threads you want to use and all these things. So for TensorFlow, you just need to pip install TensorFlow. This is normal TensorFlow stock version of TensorFlow. And if you want to see the more optimization, you can install Intel TensorFlow. So in Intel TensorFlow, we have Intel OpenMP that allows you to further tune your threading and all. So that is there in Intel TensorFlow, and that can be really useful. For TensorFlow, we have this Intel extension for TensorFlow that is to support Intel discrete GPUs. In that line, we also got Intel extension for TensorFlow for CPUs also. This also you can add in your existing TensorFlow. These are the things for TensorFlow. These are some numbers. About the multi-threading, you can see these are some parameters. These are the environment variables you can add in your workload to get the further optimizations on top of the framework optimizations. So these are called runtime optimizations. These depend on these depends on your hardware details. So yeah, all these things you can apply on top of the your AI workload optimized with AI frameworks optimized with Intel extensions. So now let's come to the neural compressor very quickly. I'll cover it. So it provides you the easy to use API. So we saw the IPEX quantization. Like so quantization, every framework provides its quantization APIs and all. But what's unique with the Intel neural compressor is it has the single API for all the frameworks. Like it has its own API, 3-4 lines of code, and you don't need to worry about the framework, what's happening, like how different frameworks use these quantization. So that is one thing. Other thing is this allows you to set the accuracy criteria. Let's say, so what happens is when we quantize our model, because of the conversion to FP32 from FP32 data type to int8, uh, because we want the faster computation, so we quantize our model to int8. So in that, what happens is when we dequantize it, because ultimately like everything we need again in FP32. So this kind of thing requires approximation and all. So during that time, there might be some accuracy drop. So to handle that, Intel neural compressor provides you the feature of this accuracy aware tuning. That means you can provide that this much accuracy I'm okay with. Let's say 1% accuracy I want only, like 1% accuracy drop I'm okay with. Other than that, I mean below it, it's not acceptable for me. So you can provide this thing in neural compressor with a single like config file, config one liner, and you will be able to achieve that. So it will do all the quantization tuning under the hood. So this is some performance number, especially considering our tensor. So it includes three things here: TensorFlow optimization, neural compressor optimization, and also our latest 4th gen AMX feature. So in the baseline, you can see stock TensorFlow on 3rd gen CPU Ice Lake. This is having FP32 data type for inference. So baseline, you can see 13.06 of through FPS you got, and then when you enabled oneDNN, you got 1.5x of speed up for throughput. You got 20.54. Now, if you have quantized your model, we also see the quantization benefit in IPEX notebook. It gave 3x, 4x of speed up. Here again, we are getting this. But here with neural compressor, you have the control on your accuracy. So that is the advantage with ink. So here again, we got on top of this oneDNN enabled, we got 4x of speed up, 3.9x of speed up. And now all these things were happening on our third gen CPU. Now, if you run it on our fourth gen CPU, that even optimizes, and that has even got better hardware features. That one of the hardware feature is AMX, Advanced Matrix Extension. So if you run on the same workload on the fourth gen, you'll be able to see 4.8x of speed up on top of ink quantized model. So overall, you could see like you gain 30x of speed up on our third gen FP32 with fourth gen and quantization. This is for inference. So yeah, you're free to use these things, oneDNN, neural compressor, all these things for the hackathon. You should see this kind of benefits. So yeah, this was mostly my presentation. If you have any questions, yeah, feel free to uh, ask. This is the overall Intel offering for AI. So, but yeah, anyway, like we are open for the questions now.
Hi participants, if you have any questions, please feel free to drop in the chat box, and the moderators and the speaker would be happy to help you with.
So about the OpenVINO, Rohit, so this is mainly for AI analytics part only. But with OpenVINO, like you'll have to do more things like but what with oneAPI AI analytics toolkit, it's even like easier to apply all these optimizations, particularly if you are using Intel neural compressor. It's similar kind of speed ups you can get. And yeah, after doing applying all these, if you have any queries and all, we have the Discord channel. You can definitely post your queries there uh, while applying all these optimizations in your pre-existing workload. Yes, Varun, slides will be shared in PDF format. And after this, you will get a survey form. You can give your feedbacks for the presentation, and the things are shown here. How does oneAPI support real-time streaming object detection? Are there any specific tools or techniques that are particularly useful for type of application? Uh, Tools or techniques. So your existing things can do everything. You just apply these for the framework level optimization. For real time, there is no such specific thing. It just it depends on the framework, and we provide the optimizations for framework. But in general, we see mostly on CPUs, batched inference is faster. gets more inference speed up. Same question. AI kit cannot be downloaded for Mac OS. Only base kit can be downloaded. Uh, you can use dep cloud if that kind of issue is there. But AI kit, I think it can be downloaded. Yeah, analytics toolkit.
Vasudha, there are some questions. Do you want to call it out for Aditya?
Yes.
Yes, yes, Kavita. So, yeah, Aditya is already seeing the question. So, Aditya, so one question is like, what are the other optimization techniques that can be used to improve the performance and efficiency of deep neural network beyond quantization, tuning, and model compression?
Uh, Other than this, I think one file mentions here is this runtime extension. These can be like really beneficial. Uh, like these give you the control over your hardware cores and all, like how your threading is happening. So this multi-threading is really important. These can be added, and
Yes, Shashi. So we have already, so Aditya have already explained the other optimization technique in the slides. You can check the slides later. So next question is, um, can you explain how oneDAL handle feature engineering and selection, and what are the best practices for optimizing feature sets for different types of model?
uh, this question, right? So what are some other optimization techniques? Okay, not this one. For SSH, Rohit, we have the link we can share. Vasudha, can you please share that
Yes, yes, yes,
SSH
Aditya.
link? Which question you were talking about, Vasudha? What are some other
So
optimizations?
this
Okay.
is question from Shambhavi, just above the optimization technique question. Can you,
Okay. Can you explain
yeah,
oneDAL? Yes. How oneDAL? What are the best practices to optimize for different types of models? How oneDAL handles features engineering and so I think you don't need to. I mean, use oneDAL explicitly to handle all these things. You just apply that intel extension, and then for big data also we have big DL. So these are some kind of extensions you can apply. You don't really need to work on oneDAL because oneDAL is a low level library. It's written in C, C++. So at a framework level, a library, Python library level, you just uh, need to follow the scikit-learn extension, apply the scikit-learn extension or XGBoost or modern, or even for big data, we have big DL. Hold on.
thanks, Aditya. And the next question is, what is the key difference between using oneDAL and oneDNN together versus other mixed data analytics and machine learning libraries such as TensorFlow and scikit-learn?
Uh, what are the key differences between using oneDAL and oneDNN together versus other mixed data analytics and machine learning libraries such as TensorFlow and so alone, like oneDAL and oneDNN cannot be used alone. They are just optimizations provided for these frameworks, TensorFlow and scikit-learn. So yeah, I mean, this versus other mixed. So yeah, answer is like you cannot use oneDAL and oneDNN alone. They are just the optimizations provided under the hood. Let's say oneDNN is optimizing your TensorFlow, and oneDAL is optimizing your scikit-learn. Are there any specific use cases where one approach is more effective than other? Uh, approach. I don't get this point. Like, what kind of approach? I mean, for deployment purpose, it's definitely recommended to use the all those uh, touch script mode and all. For TensorFlow, also you can freeze your model to get the better performance.
And Aditya, so some of the participants are asking, like, is there how one API analytic toolkit handle the integration of multiple modalities such as CT scan, MRI, and X-ray? So they are asking, are there any specific libraries or tools that can be useful for this kind of use cases?
How does one API handle the integration of multiple models for use in? Are there any specific libraries or tools that are particularly useful for this task? Multiple modalities. So it depends on the like which what are you using? Like if you're using CT scan, I think ultimately like all these things will be using some framework, if not OpenCV or all these are like optimized with Intel Intel libraries. OpenCV is also optimized with one of the Intel library, that is IPP. And then if you have some other thing you are using for this, you can let us know. Multiple modalities. Yeah, if you are using something, and if you want to get the optimizations and not able to apply, yeah, feel free to post it on Discord. We'll be able to see it in detail and able to help you for sure. Some of the questions like I'm not able to understand in detail. Okay. One API to improve the accuracy of how can I pre-process. So AI Analytics Toolkit provides the extra optimizations on top of, let's say, if you're using the pandas for pre-processing, yeah, you can use the mode in. So accuracy wise, Intel these optimizations does not, I mean, don't have anything to do with. They are all about the speed up of your workload on Intel hardware. So to improve the accuracy, AI Analytics Toolkit might not really help. It's all dependent on your model type, which model you are selecting, and all these hyperparameter tuning. So for hyperparameter tuning, we have SIGOPT from Intel, but that is not really relevant for this hackathon. So all these things, it depends on your model selection and hyperparameter tuning accuracy wise. Otherwise,
Uh,
it,
Sorry
yeah.
to interrupt you, Aditya. Can you just give some insight about the Intel AI reference kit? Because I think the participants are asking for some kind of end-to-end tools or reference. So if you can give some insight so that it will give a clue to the participants how they can get started from end to end.
Yeah, sure, Sudha. So I've opened this AI reference kits. They have like various use cases end to end, like workloads and where Intel optimizations can be applied. So you can see various use cases. And for all these, we also have the GitHub repos. You can see here, there will be some kind of pipeline where it will show that what optimizations we have added here. So data generation here, when NumPy and SciPy was being used, you can use Intel distribution for Python. And similarly for data pre-processing thing, instead of Pandas, you can use Modin. Yeah, so so there are like multiple reference kits with their GitHub repos. You can definitely check these out. Let me open one more. So if you see this NLP disease prediction, or open it, download Git, it will open the GitHub code. So here, this is the actual pipeline, and we have added all the optimizations possible. So it was a PyTorch based clinical BERT model. You can use Intel extension for PyTorch during training, and for inference also you can use this Intel extension for PyTorch, and yeah, further optimization, neural compressor you can add. So all this flow is given here, all the code is given here for your reference. Reference kit is here. Yeah, and yeah, for various tools and all, you should definitely check this oneAPI samples repo. This is having all the examples and samples for your for different components of AI analytics toolkit. You can see even in the getting started, you can see various TensorFlow, PyTorch, XGBoost, modern pandas, everything is there. And ink sample, neural compressor sample is also here. And for other resources, I think on the hackathon webpage, you'll see a lot of links for all these resources posted. Yeah, and if you have like very detailed question with very specific things, definitely like you can post it on Discord. Sometimes like we might need to see it in detail and then answer. So yeah, feel free to post it on Discord.
Hey, Aditya, I think we are good. If there are any questions, and the participants can join us on this call.
Yeah. Sorry, Kabuta, I missed.
So I think, Aditya, we are good for today's session. If there are more questions, the attendees can join us on this call.
Yeah, just one last thing I want to check is it available for Mac OS also? I have seen a few questions. Vasudha, did you, Nazneen, did you see? Okay, this is not for Mac OS. But for individual components should be available for Mac OS, I guess. But anyway, it's not, you are not really a constraint on Mac OS. That is why we have this depth cloud. You have compute resources, and it's already AI analytics toolkit is there, Conda environment is there. So feel free to use depth cloud. Yeah, Kavita, I think I am done if no more question. And feel free to post it on
Awesome.
Discord.
Thanks, Aditya, for a wonderful session. Over to you, Kaushik.
Yeah. Thank you, Aditya. Thanks, Kavita. Thanks a lot, Aditya, for taking us through the entire workshop on oneDAL and oneDNN. So participants, first of all, hope you all liked and have got some insightful info about how to utilize oneAPI toolkits. So please make sure to drop in your feedback on the survey form. The survey form link is in the chat section over here. So just make sure you fill in the form. Apart from that, if at all you face any queries post the workshop or at any time, please make sure that you have joined the Discord server that was dropped into the chat. We'll be dropping it once again right now. So just join the Discord server and ask your queries at any time. Experts from Intel would be more than happy to help you and assist you over there. So these are the few things. Talking about the hackathon, oneAPI hackathon, we have another workshop coming up the next week, that is 26th. So make sure you attend the workshop. The workshop would be on sickle, specifying on how to utilize sickle. So this is what you could be prepped for. You'd be receiving information about the same. Also make sure to complete your submissions, start building up your proposals, and as the submissions should be closing 7th of May, so make sure everything is lined up. If at all at any time you feel that there are certain queries you need to address to, please make sure that you also raise your queries on Discord server. With this, we would like to wrap up the session. Today in the
Kaushik,
session,
poll was remaining. If we can run that also, is it possible?
yes, sure. We are just putting up the poll right now. So I'd ask the backend team to please drop in the poll. Yeah. So participants, this one final poll before we wrap up today's session. Which of these oneAPI AI optimizations are you going to use? The plans that you have got for your prototypes, please make sure to participate in the poll and let us know which are the oneAPI AI optimizations you are going to utilize moving forward. So thank you, everyone. Thanks a lot for joining in for this workshop. And make sure you drop in your queries. Also, please make sure that you fill the feedback form so that we are aware of how insightful the workshop was.